In the 12th question, we have the ratio of the sums of m and n terms of an AP is this. The ratio of the sums of m and n terms of an AP is this. Show that the ratio of the mth and nth term is this. Of an AP, we are looking at one particular AP, right? So let AP is A plus D and dot dot dot. It is given. Sum of m and n terms, the ratio is m square upon n square. And prove that, to prove. What are we supposed to prove? Ratio of mth terms and nth terms is equal to 2m minus 1 upon 2n minus 1. This is actually one result which you can maybe remember as well, that if the sum of m and n terms of one particular AP are in this ratio, then mth and nth term will be in this kind of a ratio. How will we prove this? Let's talk about the proof. For the proof, we can begin with this one, right? Since we are talking about the same AP, the first term and the common difference will be same. So Sm upon Sn is equal to m square upon n square, which tells me, okay, this is m by 2, 2a plus m minus 1 d upon n by 2, 2a plus n minus 1 d, which is equal to what? We have written Sm, we have written Sn, and this is equal to m square upon n square. Is it not? Yes. What are we interested in? We are interested in am upon an, which is equal to what? This is also equal to a plus m minus 1 d. A plus n minus 1 d. Keep a look out for this kind of an expression. We need to form this kind of an expression, right? So this particular thing will be simplified to what? M by 2. So 2 and 2 get cancelled. M from m square, n from n square will get cancelled. And this is this. So you divide with 2, you get a plus m minus 1 by 2 d upon a plus n minus 1 by 2 d, which is equal to m upon n over here. This is important, right? This is important. And from here, I need to reach this particular point. So basically, this m and this n can be replaced by anything, right? Okay, we can put some particular values, let's say 5 or 6, we can put 10 or 12. So can we also put such a value that this m minus 1 by 2 transforms into m minus 1? And this n minus 1 by 2, we put such a value of n such that this transforms to this. So m minus 1 by 2 is equal to this. This is 2m minus 2 plus 1 will be 2m minus 1. Okay. So we do this calculation in the rough. M minus 1 by 2 has to be replaced with m minus 1. So this m over here, this is question mark. This m minus 1 will be 2m minus 2 will be replaced with this. M will be replaced with 2m minus 1. This m will be replaced with this. So now, once you have done that calculation, m is replaced with 2m minus 1 and n is replaced with 2n minus 1. Replace. Because this is true for all values of m and n on the left hand side and right. This tells me, okay, this becomes a plus 2m minus 1 by 2 d, a plus 2n minus 1 by 2 d. On the right hand side, this becomes 2m minus 1, 2n minus 1. This is what you get. Okay, and what is this equal to? A plus, this becomes m minus 1 d. This becomes a plus n minus 1 d. And that is equal to 2m minus 1 upon 2n minus 1. What is this equal to? This is nothing but mth term. Nth term is equal to 2m minus 1 upon 2n minus 1. That's what we wanted to prove, and that's the complete proof of this one, right? So the important thing is this step over here. m is replaced with 2m minus 1. When you are given the sum of n terms and the ratios, so for getting the ratio of nth terms, you replace m by 2m minus 1. That's what you do. Right. That's the 12th question for us and the proof of this complete question.